So this is a new type of inverse problem where there's more than one thing going on at the same time. They're, like, if you remember from Algebra 2, they're functions within functions. So we're just going to evaluate one part and then evaluate the outside part. First thing I just want to go over real quick is this arc notation that you might have seen on the worksheet from in class. It's really another way of writing the inverse. But a lot of times it means that we're only going to use the inverse values from those graphs that you did. So really, there should only be one answer, which is nice. And that they will come from the parts of the unit circle that are highlighted in yellow. You might want to kind of make a quick sketch of this or mark it off on your own unit circle. Since they're not marked on here, cosecant goes with sine, so you're going to look for cosecant values there. Secant will go with cosine, and then cotangent will go with tangent. Notice that sine and cosine, or sine and tangent, have the same ranges that we're going to use. So let's look at some examples here. So if we're going to take the sine of the arc cosine of 1/2, remember that this part is just telling us to do the inverse. So I'm going to look for the inverse cosine in this part of the unit circle, the inverse cosine of 1/2, which is going to be in the first quadrant. The inverse cosine of 1/2 is pi over 3. So I just leave that like it is. So I did the inside part, cross that off, I already took care of it. Now I'm going to find the sine of pi over 3. So still looking at my unit circle, I'm right here. I'm going to look at the y value, and I see that the y value there is root 3 over 2. So that's my final answer. Here's another one, the arcsecant of -4. So the secant goes with cosine. So my final answer is going to come from somewhere up here again. But first thing I need to do is find the secant of -pi over 4. So remember that our negatives are going this way. So that's like the same as 7 pi over 4. And the secant is 1 over cosine, or 1 over x. So the x value there is root 2 over 2. So I want the arcsecant, but now I flip it. I want the arcsecant of 2 over root 2. And I'm not even going to rationalize this right now because I'm about to do another operation here. I'm about to take the arcsecant of that. So you'll get a kind of weird answer here because we start off with -pi over 4, and you might feel like, hey, aren't I just undoing this? But when I look for the arcsecant of 2 over root 2, remember I want to be up here in the first quadrant, and -pi over 4 was down here. So when I look only in this quadrant, the arcsecant of that, where, secant would be 2 over root 2, would be at positive pi over 4. So my final answer for that one was positive pi over 4. One more, now we're back to using the inverse notation that we're used to with that -1. It's fine, they're interchangeable for us right now. I'm looking for the inverse cotangent of 1. Well, that's not too difficult. We can just think about this. This is 1 over the tangent equals 1. Take the inverse of both sides. That means the tangent is equal to 1. So really, I'm going to be finding so really what I'm finding here is the cosine where the inverse tangent is also 1. So that one wasn't hard. Tangent is 1. Remember, using this range right here, tangent is positive 1 at pi over 4. So then I'm going to take the cosine of that value, and then I'm going to get root 2 over 2, and I'm done. So some things to remember. You want to work from the inside out. If you're taking an inverse, use only the ranges given. So use only the ranges that I just gave you. That's what I mean by given. Or you can go back to your worksheets with the graphs on them and use only the ranges from those graphs. But I think the little unit circle that I was just using here will probably be the easiest. And you should remember that with the reciprocal ones, if we have cosecant of, let's say the inverse cosecant of something like 2 over root 2, that's the same thing. If we take the reciprocal of both, that's like taking the inverse sine of root 2 over 2. So you just flip it. Flip this, and then we're done. So it shouldn't be too much more difficult than stuff we've been doing, and you'll be using your unit circle again.